Good afternoon, everyone. My name is Orna, and I'm going to be your host today. Welcome to our webinar, Effective Laboratory Solutions as Key to Six Sigma Improvements. A few words about NewTech Group. We work closely with quality control and research and development laboratory professionals within varied industries, such as food and feed, pharma, and agriculture. Our solutions help automate and alleviate many common, repetitive, tedious practices commonly used in every step of the quality control lab, from sample prep through agar pouring and colony counting. Other solutions can be used for analysis of water activity, color, shape, and size. Effective laboratory solutions are critical to building a quality program that ensures both product safety and quality. In today's webinar, specific practical applications where lab solutions and automation played a critical role in overcoming failures and making Six Sigma improvements will be discussed. We will have time for questions at the end, so don't hesitate to post your questions throughout the presentation in the chat box, and we will do our best to answer. At the end of the presentation, we'll also post a link to a short survey in the chat bar, so please take just a few moments to complete it. I'd like to introduce our presenter today and Senior Application Scientist, Dr. Brady Carter. Many of you have heard Brady speak in the past. For those of you who have not, Dr. Carter specializes in water activity and microbial safety. He earned his PhD and master's degree in food engineering and crop science from Washington State University and has 20 years of experience in research and development, has authored numerous white papers, and has vast experience in instructing and training on water activity and microbial safety, both locally and internationally. Hi, Brady. Take it from it's yours.
Thank you. And welcome, everybody. Thank you for joining us for our webinar. Appreciate your time spending with us, and hopefully it will be, you'll find at the end that it will have been worth your time and worth your while. As Orna introduced, we're going to be, the purpose and the focus of this webinar is going to be looking at examples, case studies where there was a problem, a challenge, a root cause analysis was done to find out and try to discover what the source of that problem was. We were brought in and through our consulting services provided assistance in that process, and then from what we learned, the information that was provided, we were able to make recommendations for improvements of ways to be able to avoid those problems in the future and then even enhance the products themselves. And this will cover, in terms of the solutions that were utilized, cover the whole range of product offerings from NewTech Group. As Orna introduced, NewTech Group is a distributor for several different types of equipment, covering everything from automation in a microbiology lab to flow cytometry. You can see an example here of sort of the workflow of these automated solutions, how they can be implemented in a laboratory setting and offer solutions in terms of preventing problems from happening, as well as overcoming problems that have occurred. So up here at the top, you see pictured the examples of the items that are used for automation in a microbiology lab. Water activity instruments, we'll talk about automation, we'll talk about water activity instruments, we'll talk about imaging and utilizing imaging. What we won't spend a lot of time on today is flow cytometry. Primarily, it's used for pollen viability and really the scope of a different type of a webinar. So the case studies that we're going to cover today include looking at caking problems with a nutraceutical company, rancidity problems with a bakery manufacturer, moldy pet food problems for a pet food company, adulterated spices for a spice ingredient company, and then limited microbial lab workforce for a food manufacturer. So first of all, the nutraceutical powder. So in this situation, this was a company that was manufacturing an enhancement powder. So something like a protein powder or a probiotic powder meant to enhance performance. It was delivered as an instantized powder. So you came in a jar or a can. You add it to water or to milk. You mix it up, and it becomes a drink. And then you drink that, and you get the benefits from that drink. So and there's lots of these products that have come about over the last decade or so, very popular for use to try and improve health and improve performance. So great product. The only challenge was, and the challenge that they were seeing was that this product at times was showing up to the consumer caked and clumped. And the problem with that, with a powder that's supposed to be instant, is that when those cakes and clumps, the caking happens and those clumps are formed, they aren't easily dissolved into the solution or into the fluid that's being added. So what you end up with is a drink mix with lots of bits or clumps in it. And those are going to, when it's consumed, those come in as a big chunk with a blast of whatever flavor there is, typically not desirable to a consumer. So they were having problems with consumer complaints about these cans of instant powder showing up clumped up cake. They can't get them in. They can't get them to easily mix into a drink, and so they were rejecting that. Weren't going to use it anymore. So it was causing problems for this company, gaining a reputation and having to replace product for consumers who weren't happy. So obviously, in terms of monetary impacts, this would have a significant effect on sales, as well as interrupting normal distribution of the product, because not being able to ensure or guarantee that it's going to show up free flowing and ready to be used as a drink mix. So we were asked to help, brought on for consulting purposes, and of course the first steps we took was to look for a root cause analysis. And then to do this, a common methodology is to ask the 5 whys, or 4 whys in this case, but the process is to ask why questions until you get to and down to the root of the problem. So we know the problem was that the product was caking and clumping. And so the first question is, why did this happen? And the thought is that it was because it got wet. So if it prematurely was wetted up prior to delivery, then that would result in caking and clumping. But why does getting wet cause it to cake? Well, this is an amorphous powder. Spray dried powder, they typically exist in an amorphous glassy state, which is a metastable condition where these powders will stay free flowing. However, if they experience a glass transition, which can be induced through the addition of water or for water uptake, also can be induced by an increase in temperature. But if this glass transition occurs, then that can be problematic. That will lead to caking and clumping. There's lots of studies that have related the glass transition to changes in textural and functionality of spray-dried powders that are in a amorphous glassy state. So why did this glass transition occur? What induced it? Well, through the adsorption of water, there was also a water activity increase on this product. And if that water activity goes above what we call the critical water activity for glass transition, then a transition will occur that results in changes in textural properties and can lead to, of course, caking and clumping. Well, then why did this water activity increase? because the real problem here was that they were making this product and it was fine when it was at the factory and at the warehouse, but at some point before it was delivered to the consumer, this process was happening and this caking and clumping, and so based upon our looking for that root cause, we know that the water activity increased to cause this. But how did that happen? If it was processed to a proper or a low enough to be below that critical water activity, what could have happened during that time between when it was made and when it was to the consumer that could cause the water activity to increase? So the root cause of this could be improper processing. If the product wasn't processed and went into the can at the right water activity and water activity higher than the critical value, that certainly would immediately start caking and clumping. But more likely is that something happened with the packaging, and this product was exposed to high humidity that was allowed into the can or container or package or whatever it was, causing that water activity to increase, which then led to that glass transition. So we can visualize this through the use of a moisture absorption isotherm. So an isotherm or a moisture absorption profile, we see water activity on the x-axis and moisture content on the y-axis. So water activity versus moisture content. And this is what's known as a moisture absorption profile or isotherm. And this is all done at one particular temperature. This is a particular type of isotherm called a dynamic isotherm. These dynamic isotherms are characterized by very high data resolution. So each one of these points represent an actual data point collected in the isotherm, versus the more traditional way of doing isotherms through what's called DVS, which then you get data points at regular intervals, and the sample sits and equilibrates. So this is a little bit different way of doing isotherms through a dynamic process, but the result is that you get these very high resolution isotherm curves, and they're representing real time what's happening with the sample. And in this isotherm curve for this spray dried powder, what we see is that there's a very distinct change that's occurring at a specific water activity at about 0.42 to 43. That's resulting in a much faster uptake of water without a consequential drastic increase in water activity. And that's due to this glass transition that we were discussing. There's a transition occurring due to this phase transition that results in the sample increasing, or the matrix increasing in mobility, and suddenly opening up lots of different water binding sites. So water has places to go. So as you increase the moisture level, you don't experience a change in water activity as distinct because of the availability of water binding sites. And that's why this curve looks this way. What's most important here, though, is where is that critical water activity? Because the product will stay free flowing down in this range. It's in that metastable glassy state. But if it moves to water activities higher than that point where that inflection happens, this is where caking and clumping starts to happen. So we have a free flowing powder. If water's added and it's absorbed, it follows this isotherm and takes up water. If it moves past that inflection point, then you start to see caking and clumping. So the critical water activity, where that inflection happens, becomes very important for the stability of this product. So if they can process the powder to a water activity less than this, and by the way, this critical water activity will move to lower water activities as you increase temperature. So if you have both temperature abuse and humidity abuse, that can even be more problematic. But having an understanding of where this is means that they can process to water activities lower than that critical level. And then the next key piece is to prevent it from going higher by packaging. So in this case, the packaging has to have a permeability properties that won't allow large amounts of water to move through the packaging, water vapor, when it's exposed to high humidity. That's called the water permeability or water vapor transmission rate of the packaging. And so that has to be low enough or good enough, low being better, to prevent enough water vapor moving into the package to result in that water activity going high enough to move past the critical point. So if we introduce packaging, and that packaging is effective when water, when it's exposed to high humidity and water could be absorbed, the packaging is preventing it from getting to the product itself. So as long as it does a good enough job to prevent it from moving past that critical water activity, even if it does increase, the packaging protects it, prevents it from happening. And we can model that whole process. So we can figure out exactly where that critical water, once we know that critical water activity, we can figure out what type of water vapor transmission rate does the packaging have to have in order to prevent it from moving above that critical water activity given a certain set of storage conditions. So the solution is to look at this packaging, and using modeling, we can use Fickian diffusion modeling to look at what is the required permeance or permeability through this packaging that would be needed in order to prevent this caking and clumping happening by the water activity moving past the critical value. And so what you find out through modeling is that different types of packaging, of course, have different permeance values or water vapor transmission rates. So aluminum foil has a much lower WVTR value than does plastic. So it's a more effective protection. It's also more expensive. So there's give and take in terms of what packaging to use. So the advantage here is it's, of course, lower cost, could be more easily handled. Whereas with the aluminum foil, it's more expensive. To switch to it requires some production changes, but the advantage, of course, is that you're much more protected. And so if we do this modeling, we find out that a certain type of plastic has a water vapor transmission rate that's good enough to prevent the water activity from moving past the critical water activity, given the worst case scenario set of storage conditions, then that could be a viable option. But if not, and what we found was that with this particular company, they were using a aluminum lined can, but the seal was not effective. And so there was leaking going on through the seal of the lid. So when we were able to take care of that and do new calculations for water vapor transmission rates with a nice sealed lid, then it eliminated the problem and water wasn't able to get in, and it prevented the caking and clumping. Sometimes we find out that through these investigations that people are actually over packaging, and that is possible as well. So you're spending or wasting funds on packaging to have very low water vapor transmission rates when you could use a type of packaging with less stringent permeability or higher permeability at a lower cost and save some funds and still protect the product. So the key takeaway here is to know where the water activity is that's going to cause problems, and then we can make calculations and do modeling to figure out exactly what type of packaging needs to be used, or if the packaging that's being used right now is over packaged or the right type of packaging. So the Six Sigma recommendations going forward for this company based on our consulting was to first of all determine what that critical water activity was for each of the new products that are created at both room temperature and abuse temperature. And then once that's known, set a specification to make sure that the water activity value after processing is less than the critical water activity under abuse conditions. Then use a packaging model to determine the exact packaging to use for each of these different products that's optimal in terms of price, but also in terms of protection that's being provided, and that everything's being done the way that it's supposed to be, so that it will prevent the water activity from moving above the critical water activity, even after processing during storage or during transfer. And so through these implementations, this company was able to prevent the caking and clumping that was happening and have a very good understanding of what water activity range was acceptable and ideal for their particular product. Our case number two, this is a bakery company that was making a baked snack, a puffed baked snack. And they're making this product and shipping it out to consumers. It's a popular product. It has some advantages, but The problem is that it's showing up to the consumer, and they're starting to detect rancidity. And the question is, how is this happening? Because the water activity specification, and I should correct myself, what was being used was a moisture content specification, not a water activity specification, which is at the root of what's going on here. But the moisture content specification being used for this product was extremely low. They had set it all the way down to 4% moisture, and they were getting that routinely, but yet they were still having this rancidity problem. And what they didn't understand is why that was the case. They were tried different things, lowering it even more, didn't work. The only thing that worked was to increase their moisture spec to up to 7%. So quite a bit, 3% higher than what they were doing. And all of a sudden, this product is okay. It's where they're not having any kind of rancidity problems. So they didn't understand why raising that moisture spec could have caused or resulted in a more stable product. And so that's why they brought us in to determine what is going on here. How could it be possible that increasing the moisture spec would actually make this product more stable? And so that was at the core of what we were brought in for, but also then to identify what the ideal water activity range would be for this particular product. So again, remember they're using a moisture content specification for a dried product, which based on the isotherm that we mentioned earlier, would be associated with a certain water activity at that moisture level. They're not directly measuring that water activity, but there would always be a certain water activity associated with those particular moistures. And we found out through that isotherm that when they were using a 4% moisture spec originally, their water activity was at 0.15, while when they moved to up to 7%, 7.5%, their water activity was 0.4. The 0.4 was good, the 0.15 was bad. But why? Why was this happening? How could it be possible? Was there any kind of scientific justification for them increasing their moisture spec? Now, from a purely value standpoint, having a higher moisture spec is always an advantage because most products are sold on a weight basis, and that weight's coming from water. And so it would be to their benefit to be able to use that higher moisture spec. But of course, they were concerned as to why that would actually be. Is there a justification for why that would be the case to back them up? So we did our root cause analysis. Why is this product being rejected? Because it's become rancid, and there are detectable odors associated with it. Why is the rancidity occurring if this product has low moisture? And our hypothesis was that it's because rancidity increases at low moisture. Why does rancidity increase at low moisture? Our hypothesis was that that's because lipid oxidation, which leads to rancidity, actually increases at low water activity. So then why isn't the moisture spec working? Because rancidity is driven by water activity, and by increasing their moisture spec, they also increase their water activity into a range where the product would be safe. So what is going on in terms of this lipid oxidation? In general, as water activity increases, most reaction rates increase as well. And that's true for a wide variety of different types of reactions. What's unique about lipid oxidation is that it will actually increase its rate at very low water activities, and that's quite unusual. So there is a minimum point where this reaction rate will be at a minimum, but then as you go up to higher water activities, it will start to increase the rate of the lipid oxidation because of mobility of oxygen and metal ions increases. As with most reactions, as mobility increases, so does the reaction rate, and mobility increases as water activity increases. But notice that this minimum is not at 0 or at the lowest water activity in this case. It sits right around 0.3 to 0.4. And then as you go to lower water activities, notice that the rate of the reaction starts to increase again. So how would this be the case? Well, what happens is at very low water activities, as you move and dry a product, and you're removing layers of water, and so as you do so, there are it removes what are called hydration spheres. And these hydration spheres form around metal ions, where water likes to be interact with ions. And so it forms these spheres. Well, as water's removed, those spheres disappear and start to go away. And the purpose of those spheres when they're around these ions was to prevent or protect from the formation, the catalytic formation of free lipid radicals. And these radicals are needed in order for oxidation to occur. So at this very low water activity, because these metal ions are no longer surrounded by these hydration spheres, they now become more capable of catalyzing the formation of free radicals. So you actually have an increase in the number of free radicals present, which then, in the presence of oxygen, leads to an increase in the oxidation rate. If you increase the reactants, obviously that will lead to an increase in the reaction rate. In addition, these free radicals are less likely to then be quenched because of the lack of water layers present at this very low water activity. And oxygen diffusion is actually higher at very low water activity. So all those combined lead to an increase in the rate of oxidation at very low water activities. Again, very unique to this type of reaction. Notice that the range where it's the minimum is in this sort of 0.3 to 0.5 range. We can relate this to something called the monolayer value. In a lot of cases, the monolayer value is associated with around a 0.2 to 0.3 water activity and is supposed to represent the most stable condition for any kind of material in terms of reaction rates. And the monolayer can be found through the isotherm and through some modeling techniques, but that's the reason why it's not at zero, as maybe intuitively you would think that the lower the water activity, the better. In this case, that wasn't true. And that's what this company was finding, that by trying to dry as much as possible, thinking that that would increase their stability, they were actually putting the product in a water activity range that makes it even more susceptible to oxidation. So through our investigations and through the isotherm, what we're able to find is that down at water activities below about 0.3, the rancidity rates were too high and it was unacceptable. In between about 0.3 to 0.6, in that water activity range, the oxidation rate was at a minimum, and so the product was able to achieve its shelf life without going rancid. When you got to higher water activities, though, it starts to soften the texture because of water uptake or water absorption. So there was an upper limit to where that could be, to where they would have problems. And if you get even higher, up above 0.7, then you start to have microbial concerns. So there was, the take home was, there is an ideal water activity range for this particular product. It's not at the very lowest end. It's not at a high end. It's at a very specific range. And that is due to it being at that water activity range, being the most stable from an oxidation standpoint, a microbial standpoint, and a textural standpoint. And so what we found was that the original specification, according to the isotherm, was putting the water activity down at the very low, between 0.1 and 0.2 range. That's why it was failing. They adjusted their specification up to 7.5% at a water activity of 0.4. And that was improved things because they were now in the safe range. But in reality, the recommendation would be to even a higher moisture content, up to 8%, to split and be right in the midpoint of that water activity range at 0.45. And more effective would be to then set the specification to 0.45, because the moisture content isn't what's driving these issues, it's the water activity. So as long as the water activity is at a safe range set around 0.45, then the product's going to be safe regardless of what the moisture content is. The moisture content at that point becomes simply a standard of identity. So again, this is where problems can happen if they were to set the specification based on 8% moisture, and then they made any kind of mistake in their moisture analysis, and that the moisture they were getting said 8%, but in reality it was somewhere up above 10%, the water activity would be too high from a textural standpoint. So that's why it's never a good idea to try and release based on moisture content. Moisture content should just be a standard of identity. As long as they're releasing off water activity and it's in this acceptable range, then they should be good. And it's much harder to make big mistakes like that with water activity because it has standards where water activity can be checked against known standards to make sure the instrument's performing correctly. So Six Sigma recommendations were to adjust their specification to 0.45 water activity, which should correspond to 8%. But again, moisture is a standard of identity. Shift to releasing based on water activity instead of moisture content. And because of the potential errors that can happen with moisture, it's much safer to release based on water activity rather than making an assumption that if you get the moisture right, it's going to correspond with a safe water activity. So through implementation of a water activity instrument, a fairly simple test, not a very expensive machine, they're able to prevent this problem from happening going forward and keeping consumers happy. And preventing having to recall product, again, where the cost is in the millions of dollars for having to do that. Our next case study is a pet food. So this pet food was being made to 10% moisture content specification, had been made that way for years and years, and they've had a great product through that whole time. No problem for 20 years. This pet food had gained a very popular name in terms of pet food production in the location they were located, had a great reputation. So no problems, 10% moisture content working, not measuring water activity at all, just moisture content. Then all of a sudden, they start to have customer complaints. They get product back that has been sent back to them and it's moldy. And they have to go through product recalls under fear of there being mycotoxin present, which can be very deadly to pets if consumed. So all of a sudden they went from a great product, 20 years no product, or no problems, to having to recall product. Millions, hundreds of millions of dollars lost due to recall costs as well as to having to stop production. Had to spend money to hire a public relations firm to come in and help try to overcome this issue and ease the concerns of consumers. So how could this be possible? The moisture content spec worked and worked and worked, and then all of a sudden it didn't work. And we had a bit of a sneak preview of why this is the case. So we were brought in to do consulting work. We did our root cause analysis. Why is this product being rejected? Because it's moldy. Why is it molding at the current moisture when they have never had any problems? Could be because the moisture method changed, and so the same moisture is not matching the same water activity as it was previously. Why doesn't moisture control microbial growth? Because microorganisms, they care what the energy of the water is, which is what water activity is. They don't care how much is present. So why didn't they catch a change in water activity that led to the mold? And that was because water activity wasn't being measured. Had they been measuring water activity and seen that it had changed, they would have known that the product was going to mold. And so we won't spend a lot of time talking about water activity microbial growth. If you're interested in learning more about that subject in more detail, we have other webinars that we provide about that. But basically, the growth of microorganisms is controlled by water activity as well as other factors. But there are minimum levels where organisms won't grow when everything else that controls microbial growth is ideal, such as temperature and nutrient availability. So here's a breakdown of just some groups of microorganisms. The pathogenic bacteria stop at 8.6. Mycotoxin production actually stops at 0.8. Most all types of molds stop at 0.7, and then the absolute limit for all growth is at 0.6. And again, the reason why this is dictated by water activity and not moisture content is because it's all controlled by energy. Water activity is the energy of water. It's not the free water. It's not the available water. It's the energy of water. And so if a microorganism has an internal condition where it's water activity due to whatever is happening inside of the cell, the energy of that water is at 0.95, and it encounters an environment where the energy of the water is 0.90, then water is going to leave the cell. It always moves from high water activity to low, high energy to low energy. And as it moves out, the cell loses turgor pressure, which then impacts its ability to go through metabolic processes, and so it can't reproduce and grow. And so we call that osmotic stress. The organism has to respond, and each organism has its own unique ability to respond. That's why those cutoff limits are different for different types of organisms. And they lower their internal water activity through concentration of solutes in an attempt to try and get lower than the environment. If they can, then water will move back in and they start growing. If they can't, then they have to go dormant because they can't access that water. So it doesn't matter how much water is present outside of here. If its energy is low enough such that it won't flow into the cell, instead comes out of the cell, then you've created conditions where microorganisms can't grow. And so they go dormant. Now, different organisms have different capabilities to go dormant. This doesn't kill them, though. Water activity is not a kill step. It's a control step, or a critical control point to prevent growth, but does not kill organisms. And some organisms can actually survive for an extended time at low water activity. So what was happening in this particular situation? So remember, they had set a 10% moisture content specification and had never had any problems. What ends up that prior, the 10% moisture, through their own trial and error and luck, had been associated with the water activity less than 0.7. And so that was why they weren't ever having any kind of mold problems. Well, then they switched their moisture method to a different approach. And in so doing, and we're not doing the right steps to make that possible, or using the right calibration process, so that the moisture content that was being read was incorrect. So it was showing 10%, but in reality, it was actually 12%. So 2% different. Well, if you go to the isotherm curve, that's now associated with about a 0.78 water activity. That is well above the mold point. So it's very clear why this product was molding. They weren't actually drying it the same that they were previous. And because they were using moisture and there was an error in that moisture, they had no way to determine that that was happening. So all of a sudden, 10% moisture didn't work anymore because it was really 12 and it was at a very high water activity. Had they been tracking water activity and set a specification to be below 0.7, this would have never happened. Because they would have been able to detect that something had changed and that they weren't drying the product as much as they had been previously. So previously at 10% safe, goes above 0.7 and you start to have mold. Now, one good news for them was that the water activity was still below the mycotoxin production point. So that was somewhat helpful, but still the people don't, or consumers aren't going to feed their pet food or their pets food that's gone moldy. So the solution was that if you track water activity every time and make sure that it's below 0.7, then you avoid these problems regardless, again, of what the moisture content is. In fact, you can utilize this approach to maximize, again, profitability. Reformulate so that your moisture can be higher at that water activity, up to 14%. Product's still safe, and his texture should still remain safe or good. And so now you can sell more product because you're selling, again, water as weight. As long as you use water activity as the main release specification and you know that it's below that 0.7, then there's not going to be the problem of mold growth. And they were able to maximize their profitability. So the recommendations in this case were to adjust their specification to release only off of water activity, and moisture content becomes a standard of identity only. And then through some reformulation or new formulations, try to maximize the amount of moisture in the product at that safe 0.6 water activity. And so they've done this. They've been operating now for several years since this happened, releasing completely off water activity, and they haven't had any problems since. And so they're able to avoid these problems. But had they been measuring water activity earlier, before it happened, they would have saved themselves millions of dollars. Our next case study is spice adulteration. So spices are obviously utilized as ingredients in a lot of different situations, and pure spice can have a very hefty price associated with this. This is a cumin spice that would be sold under the expectation of it being pure at a high price. And of course, then the expectation of whoever bought it is that it's going to be pure cumin. But what they're finding is that this cumin is getting adulterated through almond shells. And so these are ground up almond shells being put in there as a bulking agent, and so that they don't have to add as much pure cumin. So they can sell it as if it were pure, but in reality it maybe is 50% pure or 60%, and the rest of the 40% is just cheap byproduct almond shells. So they're getting the same price, but not using the same amount of pure product. So this is considered to be economically motivated adulteration, where the purpose behind it is to try and make money. There are other types of adulteration, some that have ill intent, intent for doing the adulteration to cause harm, and then there are, of course, accidental adulterations that happen. Why can't these almond shells be detected? Because trying to differentiate them from cumin with the naked eye is almost impossible. So why isn't some test used to try and detect that? And really, because the tests take too long, or they're too expensive, or they might destroy the product. So in this economically motivated adulteration, so you have these almond shells that are added as a cheap adulterant at normal price, but may only contain 50% of the expensive spice. Due to this happening and occurring, FSMA has actually put in guidelines now that require some type of a implementation of some sort of a monitoring tool to try and detect the presence of these adulterants. And that puts a lot of burden on the people who are manufacturing the spice, but as well with those who are going to use it as a food ingredient, because ultimately they become responsible if something were to happen. Because in this case, you're also adding a a nut type of product that could potentially lead to allergic responses when it's not known that it's there, and so no warning can be provided. So looking at these two products, the question is which one of these contains almond shells? Trying to do that just based on these images is very difficult to determine does one have almond shells in it, or which one does not. So the solution here is to use imaging. This is called multispectral imaging. It's a very specific type of imaging where images are taken at various wavelengths covering UV to near infrared, so beyond just the visible, to be able to, and it can be taught through the spectral response to detect the difference between cumin and almond shells, or anything else that's different. So if you present to the system a pure cumin sample, and you present to it a pure almond shell sample, and you teach the system to recognize that, then you can use a transformation to detect when there's something there that's not supposed to be. So with the pure, we don't see any kind of heat map or particles showing up. But in the 50% almond mixed, we can immediately see that this is a mixed sample. So this is a very fast test that the image production takes the matter of about 5 seconds. And as long as the system's been taught to recognize these differences, and you can actually don't even necessarily need to have a pure sample of the adulterant. If you have a pure sample of your product, then the system can be taught what that is and then detect anything that's present that's not it, that shouldn't be there. And so then this gives the opportunity for these companies to be able to implement this multispectral imaging as a way to monitor for adulteration using a test that's very easy to run and is almost instantaneous, non-destructive as well. So there's no destruction of the expensive spice to be able to check for this purity. So this is a way to be able for these companies to meet FSMA guidelines and requirements, but at the same time save themselves a lot of money by not taking ingredients or spice ingredients that have been adulterated. Our last case study deals with limited microbial lab staff. This is one that's very timely in terms of interruptions that have occurred over the past year or so due to the COVID pandemic. So there were situations when people had to be restricted from being able to go into work. They closed down laboratories or at least minimized the staff to try and avoid close contact. So during these times, there was still needed to be food manufactured. So these food manufacturing groups were expected to continue to produce food. But in order for them to release food, in a lot of cases, you have to have completed a microbial challenge test to show that there aren't any contaminants. And those test results have to be back before product can be released. And so they'll have either they'll contract this work out or they'll have an in-house laboratory where they send these samples, which then they're supposed to do microbial testing on them and get results back within a certain time frame so that the product can be released. So under normal staffing, you might get test results back in 1 to 2 days. But when these interruptions, now all of a sudden these test results are going extending to 5 or 6 days. So you've got products sitting in warehouse not being shipped, waiting for these test results. So why was this testing output decreased? Because of limitations, in this case due to a pandemic, but these limitations could come from any type of unforeseen interruption that could occur. So why does microbial testing require so many people? Because all the steps were being done manually. For those folks that had implemented automation options ahead of time, these interruptions were not nearly as big of a problem because they had already in place ways to accomplish this testing without having to have the whole staff available. Why haven't then all labs implemented these? Some are not willing to spend the time, the capital. Some are not just didn't know about them. Some because employees fear losing their jobs, that they're going to be replaced by automation. And so why haven't they researched these automation benefits? In a lot of cases, it's because they don't know what options are available or what can be possible to do by employees who are spending time doing manual, repetitive steps where they could now have that time available to them to do more important jobs that require skilled lab force, such as analysis and determination of what to do next. So if we diagram this, our cause is that under normal conditions, a very skilled workforce, lab workforce was available, and they were putting out a certain number of test results. Then we have unforeseen interruptions, and now a much reduced staff is available, and so consequently the output has drastically reduced, and causing there to be product that was sitting waiting for test results. So what is the solution? Well, the solution is to implement automation to eliminate the time and the labor that is required to do steps that are repetitive and can be done through automation. And that's everything from media and agar preparation to petri dish filling to pouring plates, from sample prep for dilution can be automated, the mixing process through masticators, then inoculation can be automated, then you go through incubation, the microbial counting, the colony counting that has to happen can be automated, taking a lot of subjectivity out of it, and then the data recording and management. So all of this process of from a media kitchen and preparation of plates to the actual inoculation and testing is possible to automate through solutions that are provided by New Tech Group. So the outcome was that when these automation pieces had been implemented, then it was possible for a limited staff, lab workforce staff, to be able to match or equal the output that was happening prior to there being these interruptions, because people aren't needed to handle agar, people aren't needed to pour plates, they aren't needed, not as many people are needed for dilution, for mixing. They don't have to do their own inoculations and take the time to do that, and they aren't needed to do colony counting. All of that process is automated. And in fact, during the COVID pandemic, we were able to really make a difference in COVID research due to the automation that was provided. A key one was this XY tube filling system. So this is an automated tube filling system. It can fill tubes of different sizes, everything up to flasks with a pre-specified amount of solution, and do that again and again and repeat that process, eliminating errors that can come from pipetting errors, but also freeing up the person who needs to sit there and do the pipetting to be doing more important tasks. So you may not even see a huge difference in the amount of these test kits that could be put out, but what you'll see is that the people who would have had to have been doing that are now available for doing more important COVID research work and presenting those results to the public. So through these automation, this capability of this XY tube filling, we're able to help folks who are trying to, in a very fast and efficient way, put out these really critical, important COVID testing kits to be able to increase the efficiency of being able to do that through the use of automation. So our Six Sigma recommendations in terms of avoiding downtime and loss of revenue to products sitting around because testing isn't being done is to prevent this in the future for those that experienced it, is to work with the engineers from New Tech Group to determine the best automation setup for the laboratory, and then implement that automation so that you increase efficiency of a micro-testing laboratory. And then when the automation's in place, then you're able to maintain output even during times of interruptions. But you also have other advantages. You free up time for employees to spend their time doing more important tasks instead of repetitive tasks. You eliminate a lot of error that can occur by people trying to do repetitive tasks, as well as cross-contamination that can occur. These systems have ways to be able to eliminate those possibilities through the use of UV light, but also eliminates the potential subjectivity that can occur when you're trying to do things by manually, such as colony counting. And with that, that is our webinar. I hope that was beneficial. If you are interested in learning more about the consulting services that New Tech provides, I'd encourage you to go to New Tech's website at www.newtechgroup.com. You can contact me directly, or you can also send an email to sales@newtechgroup.com to get more information. Anybody who is going to be at IFP over the next in the next week, we'd also encourage you to join us there. We will be at IAFP this year in person at booth number 342.
Thank you very much, Brady. If you have any questions, you're welcome to post them in the chat box. Brady, one question we already got was about environmental conditions and whether they have an impact on product testing results during production.
Okay. So in terms of testing results for things like water activity, the environmental conditions will and can impact the results up until the point when the sample goes into the instrument. When it's in the instrument, it's sealed up against the environment. But certainly prior to that, anytime that the product itself is exposed to the room with no protection through packaging, it's subject to changing to try and match the water activity or the relative humidity of the room. So water activity, relative humidity are essentially the same thing. Water activity is measured as equilibrium relative humidity, but they're related such that if you had a product at 0.4 water activity exposed to a room at 70% relative humidity, then it's going to uptake water and it's going to change its water activity. So that's important just from a production standpoint of what can impact the final water activity of the product. But it's also important that the product that's going to be used, the sample that's going to be used for testing, not be left exposed to the environment either. So if you bring a sample in and you have it open to the room and you set it on the countertop and then wait 20 minutes before you read water activity, the water activity of that is not correct, because during that whole time it's changing based on whatever the relative humidity of the room is. So the samples that are going to be used for testing need to be protected, put in some sort of a barrier, and the cups that are used for our water activity instruments have lids to provide just that protection. But yes, certainly when product is exposed to any kind of an environment, the relative humidity of that environment is influencing the water activity.
And Brady, how important are ingredients in determining how well a product is produced?
So yeah, there's essentially a couple of main things that could potentially impact how a product's made and what its final testing results are and what its final condition is. One of those is operating conditions, both the environment around it, but also things like belt speed and oven temperature certainly have a huge impact on what the final water activity or final condition of the product will be, but so do the incoming ingredients. So it's important then to be able to track those incoming ingredients to make sure that there isn't something that's interrupted that or cause there to be differences in those ingredients. Because if they come in at, say, a different water activity, different moisture level, and you use the same processing that's been used as in all cases, then you'll end up with a different product at the end, a different water activity, different characteristics. So consistency of ingredients is the other main thing that leads to problems with production, and can be difficult at times to be able to detect. There is probably some advantage to implementing some sort of screening tests for incoming ingredients. Like we said, with the imaging is one way to detect adulterants. Water activity testing and incoming ingredients is another fairly simple way to be able to track that consistency. You know, if the water activity is suddenly changed, that there probably are other changes that have occurred, and it may not be a batch of ingredients that you want to accept from the producer.
Thank you, Brady. We have one last question, and then we have to wrap up. Regarding your presentation on the pet food company, which had issues of product recall, what did they do differently after 20 years if they measure moisture content, if they always measured moisture content? Why didn't they have the same issue before? Did they change ingredients in the pet food?
Nope. So hopefully, if you remember back to the presentation, they measured moisture content, but they switched the methodology they were using. So there was an error introduced in their moisture content measurement method. So it was still measuring 10%, but in reality it was 12% because the method was incorrect, and it wasn't giving the same results. So it was saying 10% on the screen when in reality the moisture content of the product was 12%. And so that water activity with 12% was higher than 0.7, whereas at the real 10%, which is what they've been measuring before, was down at a lower water activity. And it all leads to this idea that moisture content, because there's no way to check it through standards, is all relative. And so because they changed methods, this often happens. Different methods will give different moisture content for the same product. And so it's why it's very dangerous to try and use moisture content specification to protect it. Water activity wouldn't have failed them, because the water activity is what controls the microbial growth. So the main problem that happened here was that they weren't using water activity to release. Had they been doing that instead of moisture content, they would have never had any problems.
Oh, thank you, Brady. Thank you for this very informative presentation. As always, quite a marathon. If you have additional questions, or if any of you would like to work with Brady or any other team member on your application or evaluate possible solutions, reach out to us at info@newtechgroup.com. Don't forget to respond to the survey link that's in the chat box. Thanks again for joining us, and enjoy the rest of your afternoon.